Hello everyone. I welcome you all for online video tutorial by Department of Civil Engineering, Sai Vidya Institute of Technology. Myself, Professor Gautam, working as Assistant Professor in the Department of Civil Engineering. Today, I am going to explain about some more problems on how to calculate vertical stress in soils using Boussinesq and Westergaard equations. Okay, now let us see the next problem. Find the intensity of vertical pressure at a point 3 meter directly below 25 kilonewton point load acting on horizontal ground surface. What will be the vertical pressure at a point 2 meter horizontally away from the axis of loading and at the same depth of 3 meter? Okay, here the question is like this. There is a ground surface. Okay, on this ground surface, they had applied a load of 25 kilonewton. So they had applied a load of 25 kilonewton and it's a point load and acting on the horizontal ground surface. Now he is asking what is the vertical pressure at a point 2 meter horizontally away from the axis of loading. But in the first point is asking find the intensity of vertical pressure at a point 3 meter directly below the 25 kilonewton. That means here you applied a load of 25 kilonewton directly below this load at a depth of 3 meter. So at a depth of 3 meter, what will be the intensity of load at this point? As the first case is asking. In the second case, from the application of the load at a radial distance of 2 meter. So at a radial distance of 2 meter and at a depth of 3 meter, what will be the intensity of the loading is asking. Okay, or intensity of the vertical pressure. So in the first case, directly below the point of application of the load, where here radial distance will be 0, and the second case at a radial distance of 2 meter and at a depth of 3 meter, what will be the vertical pressure? So this is what is asking. Now let us go for the solution part. Case 1, vertical stress directly below the point load. We all know that Boussinesq equation, sigma z is equal to k suffix b into q divided by z square, where k suffix b can be given as 3 divided by 2 pi into 1 divided by 1 plus r by z whole square to the power of 5 by 2. In the first case, we know that since we are calculating pressure under point of application of the load, radial distance will become 0. And we know that z value is equal to 3 and applied load intensity, that is q, is equal to 25 kilonewton. So all the data is available. First you substitute to calculate the value of k suffix p and substitute all the values here. The value is 0.477. So once k suffix b is available, you know what is q and z. So q is 25 kilonewton and z is 3. Substitute all the values in this equation. You are going to get vertical pressure at a depth of 3 meter directly below the point of application is 1.33 kilonewton per meter square. Now in the case 2, calculate vertical stress 2 meter away from the axis of the loading. As I said, this is the axis of the loading. 2 meter away means from here to here at a depth of 3 meter means at this point you need to calculate what is the stress is happening. That can be calculated like this. We know that q is equal to 25 kilonewton and z is equal to 3 meter. In the previous case, r is 0, but in this case, radial distance is equal to 2 meter. Now apply the same formula. First calculate k suffix b. Therefore, that is equal to 3 divided by 2 pi into 1 divided by 1 plus r by z square, right? R is 2, z is 3 square whole to the power of 5 by 2, and this will be equal to 0.19, and sigma z is equal to 25 divided by 3 square into 0.19. That means kb into q divided by z square. The same I substituted here. So the value is 0.528 kilonewton per meter square. So vertical pressure at a radial distance of 2 meter and at a depth of 3 meter, how much it is? 0.528 kilonewton per meter square. Okay, and this is how you need to calculate vertical stress directly below the point of application and at a given radial distances. Okay. Now let us see the next problem. Two columns P and Q 6 meter apart. The load on the column P is 400 kilonewton and column Q is 300 kilonewton. The load can be considered as point load. Calculate the vertical stress in the soil 3 meter below the column foundation, vertically below P and Q. That means this is the case they are saying. See, there will be an ground surface. You can see here, there is a ground surface. On this ground surface, they had applied a load of P and Q, where P is 400 kilonewton and Q is 300 kilonewton. And they are separated by a distance of 6 meter. Now he is asking, what will be the load acting at this point, and also what will be the load acting at this point. This is what we are they are asking. We need to calculate what is the load under P and what is the load under Q at a not load, pressure under P and pressure under Q at a depth of 3 meter. Okay, so how to calculate? Case 1, vertical pressure below the column P. Here we have to consider the P load is how much? 400 kilonewton, Z is equal to 3 and R is equal to 0. That means for the load of P 400 kilonewton, what will be the vertical pressure at a depth of 3 meter? First we are calculating. So since R is equal to 0, straight away you can consider this K suffix B value as 0.4777, because in the previous problem only we substituted R is equal to 0. So when you solve for K suffix B, the value will be 0.477. For here also we did the same thing. So K suffix B is equal to 0.477. Sigma Z is equal to K suffix B into Q divided by Z square. So QB we calculated here, and Q value applied load at the P is how much? 400 kilonewton divided by Z stands for depth. So depth is how much? 3 square. Now you will come to know that for the load acting at a point P, what is the pressure creating at a depth of 3 meter? But at a distance of, at a radial distance of 6 meter, there is one more load we had applied, correct? No, that is 300 kilonewton. Now for this 300 kilonewton, how much pressure is acting at this point, you need to calculate, right? By considering radial distance of 6. So Q is equal to 300 kilonewton, Z is equal to 3 and radial distance is 6. Again you calculate the, repeat the same procedure, calculate K suffix P, that will be equal to 0.0085 and calculate vertical stress at this point. So Q, K suffix B into Q divided by Z square, substitute all the values, you know all the values. The value is 0.28 kilonewton per meter square. Now what will be the total load acting at this point? What is the total pressure acting at this point? It is a pressure because of 400 kilonewton and also because of pressure 300 kilonewton. So totally it will be equal to 21.2, this value, plus pressure created because of the load applied at point Q, that is equal to how much? 0.28. So this will be the total pressure acting at this point. Similarly, you have to calculate here what will be the total pressure acting under load Q. How you are going to calculate? Very simple. You have to repeat the steps again. Vertical stress below the column Q is equal to sigma Z is equal to Q divided by Z square into KB. You know that at the Q, we are applying a load of how much? 300 kilonewton and depth is 3, but there is no radial distance initially. Exactly at the point of application, there is no radial distance. Though, therefore, by considering Q is equal to 300 kilonewton, Z is equal to 3 meter and R is equal to 0, you know the formula. So you just apply, because here R is equal to 0, K suffix B value straight away you can take it as 0.477. So load is 300 and depth is 3. Okay, so calculate what is sigma Z value. It is equal to 15.59 kilonewtons per meter square. Now you need to calculate vertical stress creating at this point because of the load applied at the P, because it is a horizontal surface, correct? No, if you apply load on this point, even though the intensity of the pressure is very less, but it is creating certain intensity that we need to calculate by considering radial distance of how much? 6 meter. So again, the same steps. Q is equal to 400 kilonewton, then Z is equal to 3 and R is equal to 6. Okay, then K suffix B you calculated. So that will be equal to 0.0085. So calculate what is sigma z, you know the formula. So that will be equal to 0.38 kilonewton per meter square. Now what is the total pressure intensity acting at this point? So that will be equal to 15.59 plus pressure created because of the load applied at the point P. So that is how much? 0.38 plus 0.38. So this will be the total pressure acting at this point. And this is how you need to work out this type of problem. Okay. Okay, guys, thank you so much. See, the whatever I said, I calculated it. It is a pressure at point P, as I said, 21.2 plus 0.28. I just did here. Then at column Q, below the column Q, this will be the total pressure intensity, that is 16.28 kilonewton per meter. That means 15.59 plus 0.38. Okay. And this is how you need to calculate stress under soil because of the applied load by using Boussinesq equations. Okay. Thank you, guys. We will meet in the next class with another set of problems.